All right, a kind of short geometry video that will get you ready for pretty much the next test. So we'll do a short video and then we'll do some review. Expect a test before the rock trip in math. So here we go. Couple theorems. This one is a good one. It says if you have a line that's parallel to one side of a triangle and it intersects the two sides, then it divides those two sides proportionally. And that's an if and only if, because if you have a line that divides two sides of a triangle proportionally, then it's parallel. So that's something we know. The thing you got to be careful about is RT is to RU what TQ is to US. It's also RT is to TQ what RU is to US. But that does not mean RT is to RT is to TQ what TU is to QS. So look at that. RT to TQ does not equal TU to QS. You could say that RT to RQ is the same as TU to QS. Has to deal with a whole side of a triangle to a whole side of a triangle, whole side of a triangle, and then this whole side. Big mistake is kids will say 5 is to 4, and then I'll tell you that this is 10, and they'll go, oh, this is 8. One, that doesn't make any sense at all, but it's just, it doesn't work that way. Next two theorems, Theorem 6.6, I'm not going to really call it that, but this one is kind of logical from the last one. If you have 3 or more parallel lines, R, S, and T, and then you've got transversals. They divide those transversals proportionally. So these little segments are proportional. This is the really cool theorem. I think it's one I always forget about. And that's that an angle bisector bisects the opposite side of a triangle into proportions of those adjacent sides. So look, AD is to DB what CA is to CB. I always forget that one, so I think that one's so cool. Let's take a look at how you use these in some examples. Pretty straightforward example. This is 70, this is 110, so I know this is 70, so I know these are parallel. And what that means is I know 14 is to 6 what x is to 9. Or said another way, 14 is to x what 6 is to 9, however you want to write that. You can use those properties that says, oh, x over 14 equals 9 over 6. You can reduce here, x over 14 is 3 halves multiplied by 14 and get 21. Good. It also works, I think 14 is to 21. Yeah, what 6 is to 9. So it's all good. Lots of ways to do that. Again, that doesn't mean, so let me clear this off, that doesn't mean if we know this is 21, if I told you that this was 15, you would have to say 14 is to 20, what 15 is to y, and y would be that whole side. So notice whole side 14 is to the entire side 20, or 21 is to 30, what 15 is to y. Good there? All right, let's take another example. The angle bisector theorem here coming at you. A is to 21, what 17 is to 34. 17 over 34 is 1 half, so A is 21 halves. Much better answer, right? I went a little quickly there. A is to 21, what 17 is to 34, so 1 over 2. Everybody good with that? Multiply both sides by 21, and you're done. Love that theorem. Love that theorem. Hint, hint, hint. Angle bisector proportionality theorem, we'll call it, or similarity theorem. Angle bisector similarity theorem. I love it. Love that. Here's that idea of the parallel lines and multiple transversals, and what do we get here in terms of corresponding parts? If we did this problem, 3 is to 6 is to 3. What 2 is to 4 is to 2. But finding M and A, you've got to be careful. So look at how I'm going to solve for A. A is to 2, what 5 is to 8. A is to 2 what 5 is to this whole side. Same thing with M. M is to 6 what 5 is to 8. So here, pretty easy, you get that A is equal to 10 over 8, or 5 over 4. Here you get that M is equal to 30 over 8, or 15 over 4. So this is 5 over 4, and this is 15 over 4. So it should be that this side here is 3 times less than that side. So take a look at how that works. This whole side is 6. A third of 6 is 2. This whole side is 9. A third of 9 is 3. Good for the big triangle. If this is 5 and that's 5/4, then this small triangle is 1/4 of the big one. What's a fourth of 10? 5/4, right? Is that right? Good. Sorry. What's a fourth of 8? Excuse me. Got it carried away. What's a fourth of 8? 2. What's a fourth of 12? 3. All right. Again, not too complicated of ideas, but I will give you lots of practice problems on Monday with these theorems, and also a bunch of proofs, because we haven't done too many proofs lately. So how to use those theorems and things in proofs. All right, kids. Peace.